Hello students! So this video here is about angle terminology with two lines and transversals. Alright, so guys, we're going to go ahead on and get started here. And we're going to give you a little bit of background information, and then we'll go ahead on and get into what we're talking about with these transversals and these particular special types of angle pairs that happens when we have transversals. But first, let's give you a little bit of background information that you'll need. So, guys, first let's start off by making sure that you know exactly what we mean by the word intersect. A geometric figure intersects another figure only if it meets, touches, or crosses that figure at one or more intersections. And guys, when we say the word intersection, what we are talking about is points of intersections. So again, a geometric figure intersects another figure only if it meets, touches, or crosses that figure at one or more intersections. And guys, when we say intersections, we are talking about points of intersection. Okay, so over here to the right, you see in this diagram here, it is showing these two figures here, or these two lines are intersecting each other. They're touching or crossing or meeting here at this particular intersection or point of intersection. Okay, so yeah. Okay, so guys, another thing that you need to know about intersections is this. Whenever two lines intersect each other, like what you see here in this first diagram, and like what you see here in this diagram, in this new diagram now. Whenever two lines intersect each other, there are four angles created. There are four angles that get created. And guys, again, folks, we've talked about how to name angles. Now, these angles just so happen to be named 1, 2, 3, and 4. Again, guys, all angles don't have to have these names. Okay, they don't have to have the names of angle 1, 2, 3, and 4. Okay, they could be. Yeah, again, we talked about other ways to name angles in our previous lesson. But anyway, so again, guys, whenever you got two lines that intersect each other, there will always be four angles that get created. Okay, all right, so guys, again, all right, so we needed to know what an intersection was, and we needed to know certain information about what happens when two lines intersect. And the reason why we needed to know some of that background information is because, guys, when we're talking about a transversal is a line that intersects two or more other lines. So again, guys, a transversal is a line that intersects two or more other lines. Okay, so as you see here in this diagram to the right over here, we've got two lines here, and they've got these two lines named as L1 and L2, and of course L1 stands for line 1, and L2 stands for line 2, right? So guys, again, they've got these two other lines here in this diagram, L1, L2, and then they've got this one line that is intersecting both of these other two lines. This line that's intersecting these two lines. Now, guys, in this diagram is just two lines that's getting intersected by this transversal. Again, guys, it could be more than two lines that are being intersected by a transversal. But again, folks, in this diagram, there's only two lines that are being intersected by a transversal here. Okay, so guys, it's important for us to know that whenever we have a transversal, a set of four angles is created for each intersection of a transversal with lines. So again, folks, whenever you've got a transversal, and guys, you can see in this diagram that we've got right here, the transversal for this diagram that is that blue line, line T. if we had to name it, we would call that line T. So that for that transversal line T, there's a set of 4 angles. A set of 4 angles is created. Yeah, that ain't quite it there. Hold on one second now. We can do a little bit better than that. I thought we could. Hold on one sec. Maybe it'll work now. All right, there we go. A set of 4 angles is created for each intersection. For each intersection of a transversal with the line, guys. And so again, that's going to happen whenever you have an intersection where you got a transversal that's intersecting your other lines. That's going to happen. So a set of 4 angles, 1, 2, 3, 4. Y'all see them 2 sets of 4 angles right there. Is always going to get created when you have an intersection between the transversal and its other lines. For each intersection. Okay, so guys, if we're going to discuss this angle terminology when we have 2 lines and a transversal, then we've got to discuss the difference between interior angles and exterior angles, because you'll hear certain types of angles that we'll be talking about in this lesson will be referred to as interior, and then some other types of angles may be referred to as exterior, and I need for you to know exactly what that means. It's very important. All right, so guys, when a transversal cuts 2 other lines, and guys, when we say cuts in this particular context, when we're talking about a transversal cutting two other lines, we're talking about a transversal intersecting. So when we say a transversal cuts 2 other lines, we mean a transversal intersects 2 other lines. So when a transversal cuts or intersects 2 other lines, the angles between those other 2 lines, the angles between those other 2 lines are referred to as interior angles. So guys, those angles that are between those 2 other lines, the angles between those 2 other lines. You see these 2 lines right here? One. Give me a sec. I'm gonna erase it. Trust me, I'm gonna erase it. That line right there and this line right here. You see it? 1, 2. Y'all see them 2 lines right there? There's only 4 angles in between these 2 lines. For this diagram, that's angle 1, angle 2, angle 3, angle 4. Now, that's it. In this other diagram, it would only be this angle, this angle, this angle, and this angle, right? 4 angles will be considered interior, or again, between those 2 lines. And I'm about to erase all of that. All right. You should be able to tell. You should be able to look at that there and see which angles are interior between those 2 lines. All right. Okay. Yeah, that's just a sloppy, but you know what? It's gonna have to do for right now, huh? Still sloppy. But between those 2 lines, if I can get it lined up right, there we go. Between those 2 lines, interior, right? And then of course, guys, the exterior ones are the ones that are the ones that are outside of those other 2 lines. All right, so again, the angles that are outside of the 2 lines. The angles that are outside those other 2 lines are referred to as exterior angles. But again, guys, the angles that are inside or between those 2 lines are considered interior. Okay? And that should make sense. So there are 4 interior angles when we have this set up here with 2 lines and 1 transversal, and there are 4 exterior angles, okay, that are not between those 2 lines. Y'all see what I'm talking about. Again, folks, you'll need to know that because when we discuss these particular types of, or at least some of these particular types of special angle pairs that are formed with two lines and a transversal. You'll need to know that. All right, so guys, if we understand the difference between interior angles and exterior angles, that's a part of us kind of getting these types of these four specific angle pairs with transversals and lines. All right, so guys, when we do have transversals and lines, there will always be four specific types of angles, of angle pairs that happen when we have transversals and lines. Now, guys, I will make mention of the fact that those other types of angle pairs, special angle pairs that we talked about before this lesson. Yeah, the other types of angle pairs that we talked about before this lesson, like adjacent angles, vertical angles, linear pairs, complementary angles, supplementary angles. Yeah. Those types of angles are still here as well. Yeah. So those other types of angles, vertical angles, linear pairs, complementary, supplementary, adjacent, those angles are still here. But we're talking about some specific angle pairs that are only named this way when we have transversals. So right here, these are four specific angle pairs that only get named this way when we have transversals and lines. But again, folks, as I just said, those other types of angle pairs that we talked about in previous lessons, they're still here, like linear pairs and vertical angles and supplementary, complementary, adjacent. But anyway, let's talk about these four specific angle pairs with transversals and lines. So guys, the four names, these four names here, alternate interior angles. And so you see how that name actually includes interior angles? Yeah, that's important. So guys, and we'll discuss exactly what those angle types are and how they look. Trust me, in just a moment. But let's handle this right here first. All right, the four names, these four names here: alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. These four names, guys, are used to describe the specific angle pairs formed only when a transversal cuts two or more lines. So guys, these names here are used to describe the specific angle pairs that are formed only when a transversal cuts or intersects two or more other lines. And guys, and these names are used, guys, whether those two lines are parallel lines. So you see how right here in this diagram, let me hold on real quick. Never mind. I'm not gonna unlock it. But you see how in this little diagram here with the yellow background, how it shows two versions of it. It shows when those two lines are parallel, and then it shows over here on the left side when those two lines are not parallel. So guys, whether those two lines are parallel, like what you see here on the right side of that diagram, or whether or not those two lines are not parallel, these four names are going to be used in describing certain types of special and specific angle pairs that happen when we have two lines and a transversal. So guys, again, those four names we're about to go into detail as far as what those four names even mean. Like again, what the word alternate. So when we see alternate interior angles, like what the word alternate even stands for, or when we see the word consecutive, well, what does that word consecutive refer to? Or when we see the word corresponding, for corresponding angles, what is that word sort of referring to, and what does it mean to have corresponding angles? What does it mean to have alternate exterior angles? What does it mean to have alternate interior angles? What does it mean to have consecutive interior angles? We're about to go into detail, okay? And we're about to dive into this thing. And guys, I'm not going to take up much more of your time, or much more of my time, because because we had to prepare all of this before actually starting to record this. And I'm not going to take up much more of your time. I've taken enough of my time, but I'm not going to take up much more of your time in describing this for this lesson on today. Okay, all right. So guys, here we go. When two angles are referred to as corresponding, what they mean, guys, is this. For a pair of corresponding angles, one of the angles is going to be interior and the other one is going to be exterior. Again, so one's going to be interior, one's going to be exterior. They're going to be non-adjacent angles when we're talking about a pair of corresponding angles. They're also going to be on the same side of the transversal. And guys, they're going to lie, or they're going to rest in corresponding or matching positions. Let me show you what we mean, guys. So if I had to pick a corresponding angle that goes with angle 1 here. All right, so guys, now when we say matching positions, and I'm going to erase that, okay? But when we say matching positions, guys, the position of angle 1 in its little set of angles is sort of like the upper left, right? So compared to these 4 angles that angle 1 is with, the position that angle 1 is in for that set of angles is like the upper left. So guys, if we look down here in this other set of angles, the angles that include 5, 6, 7, and 8, right? If we look there for an angle that's in a matching or corresponding position, the only angle that's in a matching or corresponding position, guys, is angle 5. If you get what I'm saying. That's in that matching or corresponding position. Angle 1 and angle 5 are corresponding angles. And guys, they have the other sets of corresponding angles listed out here. Angle 2 and angle 6 would also be corresponding angles because both of them are in the upper right position. Angle 3 and angle 7 are corresponding positions because both of them are in the bottom left position, that corresponding or matching position. Angle 4 and angle 8 are corresponding angles. Y'all get my drift with that, right? All right. I'm going to erase that whole matching, okay? Because I don't like the way that look. Y'all might like the way it look. I don't like the way that look, having that underline like that. I'm sorry, you just got to go underlining. All right. When you see the word consecutive, and guys, actually, they may use the word consecutive. They may not use the word consecutive, and I'll talk about what other word they may use in the place of consecutive. But again, when two angles are referred to as consecutive, those two angles they have to be non-adjacent. They have to lie on the same side of the transversal, and they're gonna both be either interior or they're gonna both be exterior. So let me show you. Like for instance, if I picked an exterior angle here, angle 1, right? So I said that they have to be non-adjacent. Okay, so what does that tell us? The only angle right now that's adjacent, first off, the only angle that's on the same side of the equation that's adjacent to, on the same side of the transversal that's adjacent to this one is angle 3. So we're not talking about angle 3 because we said that it has to be non-adjacent. So we can't be talking about angle 3 or angle 2, right? Because they're non-adjacent, because they're actually adjacent. All right, so let me just show you real quick. Consecutive, it would have to be on the same side of the transversal, like that right there, and they would both have to be, like, since this one is exterior, this one would have to be exterior. Now I'm just showing you the word consecutive right now. Now, what I'm showing you right now with these two would be consecutive exterior angles, angle 1 and angle 7. That's not what we're talking about here. Where they're on the same side of the equation, they're both exterior and they're non-adjacent. That's not what this angle pair here is referring to. All right, so I'm going to erase all of that. Yeah, I think I just erased everything that I was talking about. There we go. All right, so yeah. All right, so guys, if we had to do consecutive interior angles, like for instance, if I was choosing this interior angle here, angle 4, right? The consecutive interior angle with that one would be angle 6, because they're both interior. They're on the same side of the transversal, and they are not adjacent to each other. These two angles, they don't share a common ray. They're not side by side. They don't share a common vertex. They don't share a common ray. They're on the same side of the equation, and they're both interior. So again, guys, they have here the only examples that could work for consecutive interior angles written. Angle 3 and angle 5, angle 4 and angle 6. Y'all can see that written there, okay? It ain't just my voice you hearing. You can see that we're talking about angle 4 and angle 6 is one example of consecutive interior angles, and then another example of consecutive interior angles would be angle 3 and angle 5. Okay, all right, awesome. All right, so that's what they mean when they say consecutive. When they use the word consecutive, again, guys. They could use consecutive interior angles like what I just showed you here with angle 4 and angle 6, or angle 3 and angle 5. But again, guys, there are some places where they would be referring to consecutive exterior angles, like angle 1 and angle 7, like what I'm showing you right here. Consecutive exterior angles like angle 1 and angle 7, or consecutive exterior angles like angle 8 and angle 2. Well, at least what I'm trying to show you, it's acting like it don't want to do what I'm asking it to do, but that's all good. It's all good in the neighborhood. Yeah, that ain't nowhere near right, but that's okay. Like angle 8 and angle 2 would be consecutive exterior angles. But again, this thing here is not referring to consecutive exterior angles like angle 2 and angle 8. It's referring to consecutive interior angles. So again, guys, it's talking about angles like angle 4 and angle 6 that are both interior and consecutive, non-adjacent, on the same side of the equation. I'm sorry, on the same side of the transversal. Okay. All right. The last little descriptor word that we need to make sure we know that what it means is that word alternate. So there are two types of angle pairs that have that word in it, and so when two angles are referred to as alternate, those angles are non-adjacent, and they have to be on alternate or opposite sides of the transversal. So again, guys, when we're talking about alternate interior angles, of course, guys, if we're talking about if it says interior, that means that both of the angles will have to be interior, right? So if I chose angle 3, for instance, the only other alternate interior angle with that would be angle 6. Why? Why would it have to be angle 6? I'm glad you asked, folks. Okay, so with angle 3 and angle 6, they are both interior, first off, because again, that says alternate interior angles. Okay, they're both interior, and they're non-adjacent. Okay, so these two angles, angle 3 and angle 6, they do not share. They don't share a common vertex, and they don't share a common ray. So they're not adjacent. They're on opposite sides of the transversal. They're on alternate sides of the transversal. So again, examples of alternate interior angles, as you see written here, would be angle 3 and angle 6. And another example of alternate interior angles would be angle 4 and angle 5. Guys, one way to sort of look at alternate interior angles is like for instance, guys, if you make sort of like a little Z shape, it would be like those angles that would, and I really don't want to use something that looks like a congruency mark. So let me show you sort of using something like this here, and we gotta hurry up now. Really gotta hurry up now. It would be like angles like this one and this one here, and hopefully you know what I'm talking about there. Yeah. Yeah, we got to get rid of that. So like if you were to make like a little Z shape and facing each way, either way, like that or like this, it would be like those angles like that, okay? As alternate interior angles. Okay? So like 3 and 6 and 4 and 5, if you get what I'm saying. And that should make sense, what I'm saying there about like that little Z shape, okay? Yeah, alternate interior angles. There we go. Awesome, lovely, brilliant. Okay. Alright, and I'm gonna go ahead on and erase that. I don't really like the way that looks. Y'all have to excuse me. Okay. Alright, there we go. Yeah, that erased a little bit more than what I wanted to erase. Yeah. And now it's acting like it's not gonna unerase it, so it's okay. Alright. Cool beans. Okay. Alright. So again, guys, that's alternate interior angles. Let's hurry up here. Really hurry up. Okay. Alternate exterior angles would be so like if I picked an angle like angle 7, okay, the angle that would be alternate exterior with that one, it would have to be another exterior angle that's not adjacent to it, so it can't be angle 8, right? Even though angle 8 is also exterior, angle 8 is adjacent to angle 7, so it can't be angle 8, so it has to be non-adjacent, so not angle 8, and it has to be on opposite sides of the transversal. So the only other one that's on the opposite side of the transversal besides angle 8 would be angle 2. The only other exterior angle that's on the opposite side of the transversal and not adjacent to it would be like, so again, for example, guys, angle 2 and angle 7 would be considered alternate exterior angles. Alright, and again, as you see written here, the other pair of alternate exterior angles here would be angle 1 and angle 8. Okay. Alright, so guys, as I made mention of before, previously in this video here, guys, just because we've got these new types of special angle pairs that only happen when we have two lines and a transversal, doesn't mean, guys, that those other types of angle pairs that we talked about before, like vertical angles and linear pairs, doesn't mean that those types have gone away. We still have vertical angles in these, and we still have linear pairs. We talked about vertical angles and linear pairs before in previous lessons. So guys, remember guys that again, a linear pair is always going to add to 180 degrees because they're supplementary. And vertical angles are always going to be, and I'm just going to write supplements, Okay, or linear pairs are always going to be supplements of each other, and vertical angles, remember, are always going to be congruent to each other. Always congruent, or they'll always have the same measure, right? Okay, yeah, that's sloppy. All right, we gotta hurry up. All right, guys, I got just one or two examples that we can do very, very quickly, just to show you real quick with this. Always congruent, or in other words, with the same measurement, right? Same measures. Since I don't have space to write measurement, okay? All right, so just remember that. So guys, you'll always have those vertical angles and linear pairs. Again, the new types of angle pairs are the ones that we had there: corresponding, alternate interior, consecutive interior, and alternate exterior. Guys, consecutive interior angles could also be called same side interior. Okay, so that pair, consecutive interior, could also be called also called same side interior angles. So again, this type here could be called same side, and I know that's a little sloppy. Could be called same side interior angles. All right, real quick, guys. One or two examples, depending on how much time we got. Still gotta get up out of here before 11, and give this video some time to upload. All right, so guys, here, example 1. It says for the diagram, and you can see that diagram right there. Don't act like you don't see that. For the diagram, use the indicated angles to identify which other angles, if any, would complete the specific types of angle pairs formed with lines and a transversal. So guys, it says here, fill in the chart. So guys, if we were going to look at the angle A, now I'm going to just do here, I'm going to look here at this angle A real quick. All right, so if we were going to use angle A, and I've got angle A circled, okay, and if we had to pick one other angle that would be a corresponding angle with angle A, right? Which angle would be corresponding with angle A? So right now, guys, angle A is in the position of sort of like an upper left, right? So the corresponding angle with angle A, and I'm going to erase this after I write it, after I circle this. The corresponding angle with angle A, that's also in that same corresponding position, upper left would be angle E, or the angle that says E. So I'm going to write E there, okay? Yeah. All right. Now I'm going to erase these circles, or at least that circle, because. But you saw what I was doing there. So the angle that completes that angle pair. So angle A and angle E would make a pair of corresponding angles. Okay, y'all get what I'm saying here, right? Thank you. All right. Which other angle would with angle A would make a pair of alternate interior angles? The next thing here for angle A, alternate interior angles. So first off, guys, angle A is an exterior angle. So if angle A is an exterior angle, there's no way you can call angle A an interior angle, right? So yeah, there's angle A and is not going to make an exterior angle because, I mean, it's not going to make an interior angle pair because angle A is exterior. So that's none. All right, we're gonna have to hurry this up real. I'm gonna do A like fully just to show you, but like with all the explanations. But with the rest of this, guys, I'm just gonna fill in the chart after we do A. All right. So we got angle A here again. With which other angle would come together with angle A to form a alternate exterior angle? So angle A and angle H would have to be alternate exterior angles. Okay? And of course, guys, I'm about to erase that circle that I just put on angle H because because I got it in my chart right here, so we don't need that no more. Okay? Alright, cool. Alright, which other angle would come together with angle A to form a pair of consecutive interior angles? Again, folks, because angle A is an exterior angle, you can't call angle A an interior angle because angle A is an exterior angle, okay? So, yeah, that's none, okay? All right, and then here, which angle? I told you guys that vertical angles and linear pairs are still here, even though we've got these other new types of angle pairs. So which angle would come together to form a vertical angle with angle A? Which one angle would come together to form a pair of vertical angles with angle A? That would have to be angle D, or the angle that's labeled as D, right? A and D would be vertical angles. All right, again, folks, I'm going to erase that from the diagram because we wouldn't need to look at that there. All right, so now, guys, there are two other angles in that diagram that could come together to form a linear pair with angle A. Two other angles in there. Angle B. So angle A and angle B could come together to form a linear pair. Angle B, and not only could it be angle B, but it could also be angle C. Okay, we got to hurry up, guys. I'm going to just fill in the rest of this chart, and you'll just see it filled in just a moment. Angle C. Oops, I wrote the wrong thing there. Not there, but yeah, I said the right thing, but wrote the wrong thing. Angle C would be the other angle that's coming together to form a linear pair with angle A. And guys, I'm about to erase this now. Guys, I'm just going to fill in the rest of this so you can see it. So you can see it, guys. And depending on how much time I got here, I may or may not show you another example. Okay, so guys, that's this chart here filled in. I think I may have just enough time to show you very, very briefly another example, but give me just one sec here. Okay, guys, super quick. This last example here, example 2. And I've really got to go, folks. Example 2 here. If the measure of angle 1 was equal to 38 degrees and the measure of angle 6 was equal to 111 degrees, find the measurements of all the other angles. All right, so guys, if we had to find the measurements of all the other angles, guys, remember with this, guys, you can use the linear pairs and vertical angles, and that's what you'll have to do here. Wow. Okay. Yeah, that's fine. It's gonna have to be use vertical angles and linear pairs to do this. All right, and I got to go. Ooh, I got to get up out of here right now. Pairs. All right, so linear pairs with 38 degrees. Angle 2 would have to be 142, and angle 4 would have to be 142 degrees. Vertical angles with 38 degrees. This one would have to be 38 degrees as well. Okay, I got to go. All right, vertical angles with 111. This one would have to be that. And linear pairs with 111. This one would have to be 69. And this one would have to be 69 degrees as well. That's how you'd have to do it. That's it, folks. I hope it's been helpful. I got to go. Bye. Hope it's been helpful.